Now let's just move on further towards the topic in which we will discuss about the number of tangents from a point on a circle. So let us suppose if I'll perform a particular activity in which I do have a circle such that the point is lying inside the circle. So let us suppose if I'm just performing an activity in which I just wanted to see the number of the tangents from a particular point on a circle. So I am taking the first case in which I am taking a particular point which is lying inside the circle. So let's just see that how many number of tangents we can draw if a point is lying inside the circle on a circle. So let us suppose if I'm just talking about this particular case, as you can see over here, this particular point is actually lying inside the circle. It is lying inside the circle. So if we just wanted to draw the number of the tangents from this particular point on the circle, so as you can see, we have already drawn two lines over here. This is my line number 1, this is my line number 2, and you can draw even more than these two lines. Then you will definitely see that whenever you will draw a particular line that will pass through this particular point, then that line will definitely intersect this particular circle at exactly 2 points. As you can see over here, for these two lines, you can see if this line, if we are talking about this particular line, then this line is actually intersecting this circle at 2 points. This is the point number 1, this is the point number 2. Similarly, this line is actually intersecting this circle at 2 points again. This is the point number 1, this is the point number 2. So it means that there is no tangent for this particular circle since the point is lying inside the circle. So whenever we have such a case when the point is actually lying inside the circle, then we know that there will be no tangent to the circle. You can see all by yourself by this particular activity that if the point is lying inside the circle, we are not able to draw any particular tangent to a circle. Now let us suppose if I am just taking a particular point on the circle, not inside, I am taking the point on the circle. So let us suppose if this is my circle and this is my particular point. So as you can see, for this particular point there is one and only one tangent. We have already performed this kind of an activity in which we have seen that for any particular point which is lying on the circle, there is one and only one tangent, and this tangent is actually unique for this particular point. So hence for this case, when the point is actually lying on the circle, then there is only one tangent, as you can see over here. So hence it means that there is exactly only one tangent for such a case. But let us suppose if I'm just taking the point outside the circle, so this is my third case in which I'm just taking the point which is lying outside the circle at any particular point. So from that particular point, you can draw two tangents to a circle. Let's just see this. So let us suppose if this is my particular point that I'm taking which is lying outside the circle. So from this particular point, you can see that you can able to draw two tangents. This is my tangent number 1 and this is my tangent number 2. So we can draw two tangents to a particular circle whenever the point is actually lying outside the circle. So hence we can say this thing that there are exactly two tangents. There are exactly two tangents for this particular point whenever the point is actually lying outside the circle. So these are the three cases that are related with the number of tangents from a particular point when the point is lying inside the circle, on the circle, and outside the circle. So let's just talk about an interesting fact which is related with this particular kind of a tangent in which the point is actually lying outside the circle, and we have two tangents over here. So there is a term which is related with this, which is nothing but called as the length of a tangent. What is the meaning of length of a tangent? So the length of the segment of the tangent from the external point P and the point of contact with the circle is called as the length of the tangent from the point P to the circle. So let's just see the definition by the figure. So let us suppose if I'm just taking the third case from the previous one. So as you can see over here, there are actually two tangents. You can see all by yourself. There are exactly two tangents over here whenever the point is lying outside the circle. So what is the meaning of length of a tangent? So if I'm just talking about this PT1, this PT2, these two are nothing but called as the length of the tangent. So this segment PT1, the segment PT1's length is actually called as the length of a tangent. So PT1 and PT2, they are nothing but called as the length of the tangents. They are called as the length of the tangents. Now there are various other properties that are related with these two length of the tangent, or these two tangents, that is PT1 and PT2. So let's just see what are the properties that are common with these two particular tangents. So I hope the concept of length of tangent is all clear to you. Now let's just move on further towards the properties that are related with this PT1 and this PT2.